Welcome to the presentation of JavaFX Multi-touch API. My name is Pavel Šafrata. I've been working for Sun and Oracle for over 5 years, and recently I've been leading the multi-touch API effort. So today I will start with a brief event system recap to set up some terminology for the rest of the talk. Then I will provide some overview of the new multi-touch API. In the third section, I will go through all the new events and describe their behavior and some reasoning behind it. Then I will provide some warnings and recommendations for writing applications that behave well on different platforms with different input devices. And in the end, I will show some concrete code examples. So let's start with the event system. This is a picture of a scene graph tree. On every node, you can register event filters and event handlers. When an event is fired on a node, this node becomes the target node for this event, and it is then delivered in two phases. First is the capturing phase, during which the event is delivered to the event filters from the root node through all the parents to the target node. And the second one is the bubbling phase, during which the event is delivered to the event handlers from the target node back to the parent node, to the root node. Any filter or handler along the path can call consume on the event, and this finishes its way through the scene graph. So the usual usage is just register event handler on the node that wants to react on the event and consume the event there. So, for example, if you have a button, you register mouse clicked handler on this button, and then during the capturing phase, there are usually no event filters. And when user clicks the button, the target node is usually some of its children, for example, the label there. So during the bubbling phase, the label ignores the event. It bubbles up to the button. The button handles it, consumes it, so it doesn't affect further parents. We have hierarchical event types. So the blue rectangles represent the actual event types that are delivered as events, like mouse press or key type. And the gray rectangles represent their parents. You can also register filters or handlers to them, and they will get all of the subtypes of the registered event type. So there are two ways of registering event handler. You can always use the add-event-handler method and give to it the event type you want to register to and the handler. And for the commonly used events, we have also direct methods, like in this case, set on mouse pressed. So those two calls are more or less equivalent. So let's move to the multi-touch. So we did our best to provide a generally uniform and easy-to-use API while approaching the native behavior as closely as possible. So the idea is that you will study our API, write your application in the spirit of write once, run everywhere, and the applications will run everywhere and will behave slightly differently on different platforms to provide to the users what they are used to. So this should make users happier because the applications will behave as they expect, and the developers shouldn't need to be much concerned about those platform differences because it's usually stuff like different inertia speed or users doing different things to produce the gesture or something like that. For all of the new API, we used classic FX events. So there are no special delivery mechanisms or input modes to choose from. There are just all the events are generated, and the application just chooses which of them it wants to handle and registers proper handlers. The events are merged by purpose. So if you rotate mouse wheel, it generates scroll event. If you drag finger over touch screen, it generates the same scroll event. For most of the usual usages, this is very convenient because if you have scrollable content, you need just a single scroll event handler, and it scrolls everywhere it's expected to scroll. For some unusual or advanced use cases, you might need to be aware of some differences between the input devices, because the wheel cannot produce exactly the same behavior as the screen. I will show it in more detail later. So what we did to the events. This is a snippet of the event hierarchy before we added the new API. There was input event and its children, mouse event and scroll event, and there are others that are unrelated right now. So we inserted gesture event between scroll event and input event, and moved some common stuff to it, like coordinates and keyboard modifiers. Then we added events for another gestures, zoom, rotate, and swipe. And finally, we added touch event for tracking the particular touch point touches. So the important thing to keep in mind is that the events are independent. This means that there are no high-level gestures depending on low-level touches or something. All the events are generated at the same time and delivered independently. So the tree should probably look like this. All the leaf events are actually on the same level. This gives you complete freedom in to decide which of the events you want to handle in which parts of the scene graph. But if you decide to implement some more complicated combination of those handlers, you need to be careful not to implement conflicting handlers for different events produced by the same user action. So let's look more closely at the events. Mouse events are generated by touchscreen. They can be used for some easy clicking and dragging and things like that. And this makes the existing applications work with touchscreen as they are. Sometimes you might need to recognize if the events were produced by touchscreen, so we added the is synthesized flag for that. So the common gestures are recognized automatically by the platform and delivered as events. We distinguish continuous gesture events that keep coming during the gesture, have started and finished notifications and support for inertia, and one-time gesture events that represent the whole gesture with a single event. We also distinguish directly produced gestures that are produced directly on the concrete coordinates, on the nodes, on touchscreen, and indirect gestures that are produced somewhere else, usually on touchpad. All of the gestures provide the gesture coordinates and keyboard modifiers. So the continuous gestures have 3 event types for the started, performed, and finished notifications. When the gesture is recognized, it starts with the single started event, and at this time the target node is picked for the whole gesture. So all the following events of the gesture are delivered to the same node. The gesture coordinates for directly produced gestures are in the center of all the touches, and for the indirectly produced gestures it's usually the mouse cursor location. So then the performed events are delivered during the gesture, and they have 2 types of values. The delta values contain different since the previous event, and the total delta values different since gesture start. At the end of the gesture there is the single finish notification, and if there is an inertia to the gesture, it is delivered as another set of the performed events marked with the is inertia flag. So for the usual use cases, you only need a single performed event handler, and the gesture works for you, including inertia. So those are our continuous gestures currently. The first row shows the 3 event types. The second row shows the values provided by the gestures, and the third row shows their usual usage to achieve the natural behavior. So to the existing scroll event, we... I was just curious, on I don't understand the question exactly. What signals inertia?
Give a method that tells you if there's inertia or not.
Yeah.
What does it mean to say something has inertia? It's how fast you're moving when you edit.
Take
Your hand off. Go like that or like that. So if you're accelerating, if you're just going slow, that'll get dragged. If you're going fast, it will have a lot of inertia. So if there's acceleration,
inertia is
going at the edge.
you.
How fast it has to decelerate.
Yeah, when you finish the gesture and release the fingers, the content continues moving. And this is inertia. Okay. So to the existing scroll event, we added the stuff needed to support the continuous gesture, which is the started and finished event types and the total delta values. And we also added the touch count value, which is the number of touches used to produce the gesture. The rotate event provides the angle values that can be added to node's rotate property to provide the natural rotation. And the zoom event provides the zoom factor methods, values that can be multiplied with node scale properties to achieve natural zooming. So we added also the swipe gesture. It is a gesture where you press one or more fingers and move all of them in the same direction. If this gesture is recognized, it is delivered as a single event with its event type representing the swipe direction. It's usually used for things like paging. For example, you swipe to the left to switch to the next tab or something like that. The gesture is delivered to the node in the center of the entire gesture, and it also provides the touch count value.
Is that the only swipe gestures that you guys have? I mean, you can only go left, up, right, or down?
Yes. No, we don't recognize diagonal swipes right now.
So what does it do if I try to go diagonal? Does it assume whichever one I was closest to, or what does it do?
Yes. I think it's like that. I think there is some space that if you do it really exactly diagonal, it doesn't recognize any swipe. So touch events, pardon. So let me first define multi-touch gesture. It starts with first touch of the screen, continues while at least one finger is touching the screen, and ends when all the fingers are released. At every moment of such gesture, there is a set of touch points representing the particular fingers. Each of the touch points has its ID, its coordinates, and its state. If it has just been pressed, if it's moving or stationary, or has just been released. The touch events are there to track those particular fingers, touch points, to allow for some advanced or custom multi-touch logic. And they are only direct, so we don't produce touch events from touchpads, because there are virtually no use cases where you would handle them the same way, except of gestures maybe, but they have different events. So this is a situation somewhere in the middle of the multi-touch gesture. There are 3 fingers currently pressed. The first one is moving, the second one is still, and the third one has just been pressed. So the touch points have their IDs. They are sequential numbers in scope of a single gesture assigned to the touch points as they appear. So when you press the first touch point, it has ID 1, the second one is ID 2, and so on. So now I have 3 touch points, and I may want to drag different nodes by each of the touch point. So for that, I need each of the touch points to be delivered to different target node. So to make this possible, we create a separate touch event for every of the touch points. The events have event types corresponding to the state of their touch point. So this allows for the nice handlers like set on touch moved, on touch pressed, and so on. So what if I now want to write, for example, some battle game, and I want a logic where I select a soldier by pressing it by one finger, and then I press the second finger somewhere else to specify the direction to shoot at. To be able to encapsulate the shooting logic into the soldier, I need to be aware of the second touch point there as well, and it is delivered somewhere else. So to make it possible, every of the touch events contains also references to all of the other touch points. So now if I want to implement some global logic on all of the touch points, the easiest thing to do is to handle the touch event and use all of the touch points contained in it. But then I need to somehow know how the events belong together, not to compute again with the same touch points. So the events have event set ID, which is a number common for all the events that were generated at the same time and are carrying the same set of touch points. So I can just remember the last used event set ID and then ignore the other events with the same number there. The touch events are delivered to the node that was first pressed by the touch point. So if you press the screen, the node is picked at these coordinates, and during the rest of the gesture, the events for this touch point are delivered to the pressed node. If you are computing something with the other touch point referenced from the event, you can check where the other touch points are delivered. There is the getTarget method, which returns the target node for the touch point, and there is also belongs_to method, which checks whether the touch point is delivered to the given node during the capturing and bubbling phases. In other words, whether the given node is the target node or any of its parents. So this default behavior of the events is consistent with mouse events and gesture events, and most of the time it's convenient, but sometimes it's not really handy for some use cases. So we added also the grabbing API. So on every touch point you can call grab, and since the next event, all of the events for this touch point will be delivered to the node who called it or whose handler called it. So this is exactly what every node does for the touch pressed event to achieve the default behavior where all of the following events are delivered to it. You can also call ungrab, and since the next event, all of the events will be delivered always to the node on the touch point's current location. So for example, if you have a list and you drag a finger over it and you want it always to select the item under the finger. So the list implements the touch pressed handler, calls ungrab on the touch point, and then each of the items can select itself in the on-touch moved handler because it's delivered always to the node under the finger. You can also grab the touch point for a specific node. And this is useful, for example, if you have a drawing application, you touch the screen, it creates some shape there, and you can drag the shape around. So the board implements the touch pressed handler, creates the shape, and grabs the touch point for the new shape to allow for it to get the further events. You can also find out which node has grabbed the touch point by the getGrab method. So to summarize the touch event, there is a touch point which has state, ID, coordinates, and target node, and the method belongs to and grabbing API. And there is touch event which has the event types corresponding to the touch point state. There is the main touch point, the references to all of the touch points, number of the touch points, event set ID, and keyboard modifiers. So let's look more closely on some problems you may encounter on different platforms and different input devices. So different events happen together. This is mostly natural thing, but I should point out some more interesting combinations. So mouse dragging doesn't exclude scroll. If you drag a finger over touchscreen, it generates both mouse dragging and scrolling events. This is the only way how to make the existing applications work, because this is how you drag on touchscreen and this is how you scroll on touchscreen. Unfortunately, this is also the only exception from the rule that the existing applications work as they are, because nodes that handle both of those events may have problems. The only common specimen we have encountered is scroll bar. It handles mouse dragging, so it reacts to dragging the thumb, and it also handles scrolling, so it reacts to mouse wheel. If you use such a scroll bar on touchscreen, it gets both of the events at the same time, and depending on its implementation, it sometimes moves twice as fast. So this needs to be solved, and the recommended solution is to ignore the mouse dragging events that are synthesized from touchscreen. Also, swipe doesn't exclude scroll. So if you drag finger over touchscreen, it generates scroll events during the drag. When you finish dragging, it recognizes swipe and delivers swipe, and even then the scrolling inertia may continue. So you usually don't want to handle those two events at the same node, at least not in the same direction. The touch events happen together with all of the other events, so again, if you decide to implement some more complicated combinations of event handlers, be careful and think of possible conflicts. The gestures may differ for different users. So first of all the gestures don't even exist for different users. If you have PC with keyboard and mouse, you have no way to generate rotating or zooming. So if you restrict some logic in your application to those gestures, you are making it kind of platform dependent. The gestures also don't have exactly the same features in every platform, so you should always be prepared for the inertia to be generated or not be generated, depending on the conventions on the given platform. Also, building some logic on the touch count value may be dangerous, because on touchscreen you can produce the gestures by any number of fingers, but on touchpads this is very limited, because one finger moves mouse cursor, it cannot produce any gestures. And for example, on Mac there is a lot of system settings that make swipe with certain touch counts be consumed by the system before it even gets to the applications. As I already mentioned, the scroll event behaves differently for different input devices. So for mouse wheel, nothing has changed since the previous releases. There is a single scroll event generated for single wheel notch. There is no continuous gesture. In particular, there is no total delta, because there was no gesture start to compare to. On touchscreen, we can generate a full continuous gesture, and touchpads are platform dependent. On Windows, touchpads usually behave exactly as mouse, and on Mac we can produce continuous gesture as well. So please note that for the usual scrolling, you just implement the scroll event handler, you use the delta values, and it works naturally for all of the input devices. If you decide to do some more complicated use of those events, you might need to be aware of those differences. So I will show you some code examples. I intended to show you the applications I'm going to talk about on a tablet, but unfortunately I haven't been provided with a proper camera, so I will try to explain you what the applications are expected to do. So I want to write an image viewer application. It shows one image at a time, and it works on tablet, where I can drag the image to the side to switch to next or previous image. I can zoom or rotate it naturally. And the same application also works on PC, where I can drag it by mouse to the side to switch the images. I can zoom it by mouse wheel and rotate it 90 degrees by clicking the image. So there is a kind of unusual usage of the events because I am using the scroll wheel to zoom. So you will see what you need to do to achieve this. So for the touchscreen rotating, it's easy. I implement on rotate handler, and I use the angle for the rotate property of the image to rotate it. When I finish the rotation, I want to fix the image rotation to the 90 degrees position. So I implement the rotation finished handler, which does that. There is a problem here that the rotation gesture may have inertia and it will interfere with the second handler there. So I need to use the rotate event only if it's not inertia. For mouse rotating, I use mouse clicked handler, and depending on the button pressed, I rotate it 90 degrees. But this makes it rotate also if I tap the touchscreen, and I don't want to do that. So I use the event only if it's not synthesized from touchscreen. Touchscreen zooming is again easy, just on zoom handler and use the zoom factor to scale the image. Mouse wheel zooming uses scroll event because this is what mouse wheel produces, and uses it only if it's not direct. Otherwise it would zoom also if I drag on the touchscreen. For switching the images, I use mouse dragging events. I don't use it works on both PC and and the tablet. So I don't use swipe because it's not continuous gesture. It doesn't support the smooth movement of the image with the finger. And I could use scroll or touch, but I don't need to because the mouse events work everywhere. Another use case, I have some circles on the scene, and I want to drag the circles independently by different fingers. So I just remember the position where I pressed the circle and ID of the touch point that is dragging it, and keep moving the circles with the touch point. It may seem that I should not need to remember the ID of the touch point because the circle anyway gets only the touch point that pressed it, but this solves the situation where I press a single circle with two fingers, so it has to decide which of the fingers it will follow, so it remembers the ID of the first one. So the touch pressed handler, if the circle is not dragged yet, it remembers all the values. Touch moved handler, if it's the touch points we are following, it updates the position, and touch released handler resets the remembered ID. So more interesting thing is when I have a rectangle and I want to press one finger on the rectangle and then touch somewhere else, and the rectangle will jump there to the new location. And then I can release the first finger and press it again somewhere else to continue jumping like that. So I want to handle events that where the first touch point is pressed on the rectangle and the second one is pressed somewhere else. So I implement the touch stationary handler because the node that is delivered to the rectangle is expected to be stationary. I handle the event only if the touch point, the touch count is 2. Yeah, I'm not interested in events with different number of fingers. Then I obtain the main touch point, and the other touch point is the second touch point in the list of all touch points. If they have the same ID, that means that the main touch point I'm handling is the second touch point pressed. So I'm not interested in this event as well. So now I know that the first touch point was pressed on the rectangle, and I do continue only if the second finger was just pressed, so it has the pressed state, and was not pressed on the same rectangle, which is belongs to this call. So now all of the requirements have been met, so I execute the jump, and now the rectangle is on the location of the other touch point. So I grab the other touch point to be able to continue the jumping. So the events for the other touch point now start to be delivered to the rectangle. And I also want to ungrab the original finger. Otherwise, I would be able to touch the rectangle by one finger and then keep touching different places by the second finger, and the rectangle would still keep jumping because the original finger would still be delivered to it. So that's it. I wanted to show you some more cool demos on my tablet, but unfortunately I cannot. So if there are any questions.
So you only have like 4 gestures or 5 gestures. What are the future plans? Are you planning on adding more? I'm assuming in those cases you plan on adding more.
Yes, we are considering adding more gestures, and we are also considering to allow some custom gesture recognizer so that you can generate some custom gestures as you want. We are kind of waiting for the feedback from users on this API we have just introduced. Please. We don't decide between the gestures. We recognize and deliver all of them. So, so for the penning, we have it generates scroll event and the swipe event, right? So if you want to scroll something, you use the scroll event. If you want just the one-time event, so that you, I don't know, switch tabs or something, it's easier to use the swipe event. So you don't use both of them at the same time.
So you have no way to differentiate between the drag and the swipe?
No, they are the same thing actually. So you are penning with one finger and it produces the scroll event. Then you add the second finger and the scroll event with touch count 1 is finished, and the new scroll event with touch count 2 is started, and also zoom event and rotate event. Please. I have tablet with Windows 7, so I used standard JavaFX there. Okay, any other questions? So that's probably it. Thank you for attention. Thank you.